Chapter 11 review. Number 1. The RMS error is V. 5. Why is it the SDY and not the SDX? The RMS error is a vertical measurement. Okay? This is a review, page 198. Number 2. A computer program is developed to predict the GPA of college freshmen from their high school GPAs. This program is tried out on a class whose college GPAs are known. The RMS error is 3.12. Is anything wrong with that? It's way too big. In the case of GPA, what's the most that the RMS error can be off by? Well, the range is 4, so the RMS error can't be higher than 2. And actually, the RMS error is usually lower than the standard deviation, so anything near 2 sounds pretty impossible. That would be everybody either had 0 or 4. So we would expect the RMS error to be in the 0.5 range or something like that. Okay. Tudenham and Snyder, oh great, obtained the following results for 66 California boys at ages 6 and 18. We have all of that. Find the RMS error for the regression prediction of a height at 18 from a height at 6. So we have our R value. If we are predicting height at 18 from the height at 6, which one is the X and which one is the Y? So the one you are predicting is always the Y value. So this says we are predicting height at 18 from height at 6, which means we run around and measure a whole bunch of 6-year-olds, and then we predict how tall they will be when they're 18. So this would be 18, and this, oh, no, it wouldn't. 6 and 18. There we go. And my R value is what was it? 0.8. Is that a good prediction? If I measure you at 6 and I use their formula, will I be close to your 18 age, your 18 height? Yes. Really close. I mean, within a couple inches. Okay. So, what would the RMS error be? It's the square root of 1 minus 0.8 squared times the SD of 18, which is 2.5. So square root of 1 minus 0.8 squared times 2.5. So that's pretty accurate. If we were to draw the scatter diagram, that would be a very tight football, and we would only need to go up 1.5 inches and down 1.5 inches, which means 68% of the people will be within 1 vertical inch of the regression line, which is pretty good. 1 inch, or 1.5 inches. So 1.5 inches up and 1.5 inches down. 2/3 of the people will be in that window. All right, B, find the RMS error for the regression prediction of height at age 6 from age 18. Does that change my scatter diagram? Yeah, the 6 and the 18 flip. So we put 18 down here and 6 down here. And we draw a new scatter plot. Does the R value change? No. R value is exactly the same because we didn't change any of the numbers. And we do the same thing, but now we plug in the SD of 6, which is 1.7. So it's this exact equation, but we plug in 1.7. What is that telling me? What does 1 inch mean? Can you interpret 1 inch? How far off what will be? What prediction? If we go around and measure a bunch of 18-year-olds, we can use their 18-year-old heights to predict how tall they were at 6. How accurate are our predictions going to be? Well, every 6-year-old will be within 1 inch. Every actual 6-inch height will be within 1 inch of the regression line for 68% of the people. Does that make sense? Why is this number smaller than the last one? It's still 0.8 as the R value. And why is the SD of the 6-year-olds smaller than the SD of the 18-year-olds? They're shorter, right? They might be the same percentage off. So you might take the average kid and you might be off by 20%, but 20% of a 6-year-old is smaller than 20% of an 18-year-old, right? So would you say that the heights are more or less varied? Well, that's kind of a difficult question because they're taller, right? As a percentage, it might not be. Okay, you're good. All right. 4. A statistical analysis was made of the midterm and final scores in a large course with the following results. The scatter diagram was football shaped for each student. The final score was predicted for midterm scores using the regression line. So which one's X? Midterm, because it says we are predicting the final score using the midterm. So the midterm would be X. For about 1/3 of the students, the prediction for the final score was off by. How do we capture 1/3 of the students? So we have our regression line, we have midterm and final. We have our bubble. Okay. How do I make 1/3 of them higher or lower than the prediction? Well, if I capture 68, or if I capture 2/3 of the people on the inside, that would leave 1/3 of the people between there and there. How far out do I need to go to do that? 68% is really, really close to 2/3. So all we have to do is 1 SD, but wait a minute, we're not in 1 dimension, we're in 2 dimensions. It's the RMS error. In 2 dimensions, it's the RMS error. In 1 dimension, it's the SD, right? This is not a histogram. So all we need here is the R value, which is 0.6, and the SDY, which is 15. So the square root of 1 minus 0.6 squared times 15, 12. If we go up 12 and down 12 and draw the parallel lines, we will capture 2/3 of the people, which means we didn't capture 1/3 of the people. Okay? Predict the final score for students whose midterm score was 80. So how far off is 80 from the X bar? 30. So I need to go right 30, which is how many SDs? Divide that by 25, and I get 1.2 SDs to the right. So I go up 1.2 SDs, but it's not all of it. It's only 60% of that. So 1.2 times 0.6 is 0.72. So the final score is 0.72 SDs higher than the average. What is 0.72 in terms of points? Multiply that by the SD of Y, which is 15, right? Yeah. Add that back to the Y bar, which was 55. And that's our best prediction. Somebody who scored 80 on the first test is the best guess we can give is 65.8. How far off is that going to be? Well, if you take the RMS error, we would expect to capture 68% of the people using that RMS error. Okay. This prediction is like to be off by how many points? What is the RMS error? 12. So we would expect it would be off by about 12 points. That would capture 2/3 of the people. Okay. About what percentage of students scored over 80 on the final? So my my Y bar is 55, and my SDY is 15. So we have a histogram. This is 55, and I want to go up to 80, and I want this tail. How far in absolute terms is it from 55 to 80? 25. So I need to go right 25, but I need to turn that into an SD. So 25 divided by 15 is 1.6 SDs. Shade norm. Clear my draw. Go into shade norm. And I want to go from 1.66 to 5. Yeah, I want the right tail. And that tells me 5%. So 5% of everybody scored 80 or more on the final. We get that? All right. 5B. Of the students who scored 80 on the midterm, what percentage also scored 80 or more on the final? Would we expect this number to go up or down? So instead of looking at everybody, we're just looking at the people who did really well on the midterms. The percentage would go up. Now, if I were to say, if I scored 80 on the final or on the midterm, would I be more likely to score higher or lower on the final? Lower, because we would have the regression effect. We would regress back to the mean. But on average, the people who scored 80 on the final or on the midterm are more likely to get really good scores on the final. Okay, so we'd expect it to go up. So we need to find the new average. Wait a minute, we just did that, right? I just did it right here. What did we get? Is it still on my calculator? Nope. What was the answer to 4B? So if we go over here to 80, then we go up to 65.8. Oh, there it is. Yeah, it is on my paper. Okay. Does everybody understand what that number is? That is the predicted score that is the average score for everybody who got 80 on the midterm, according to the regression line. So what we did was this right here. That's 30 to the right, which is 1.2 SDs. So we go up 1.2 SDs, but it's not actually this. It's 60% of that. So we cut it off by 60, times it by 15, and added it back to 55. So basically, we went from this point on the regression line to this point on the regression line. And we end up with this column here, and that point is 80, 65.8. We don't need to recalculate it because we already did. All right? Now, we need to draw a new histogram that only includes these people. So that histogram has an average Y value of 65.8. Why don't I use the average X value? Because everybody in that column scored 80. There's no variation. Right? This is every single person who scored 80. So we have to be looking at the Y values. It doesn't make any sense to look at the X values. Okay? And I want to know how many of those kids got above 80 over here. Well, how many SDs is that? We don't use SD. We use the RMS error. And we calculated the RMS error to be, so it was the square root of 1 minus 0.6 squared times 15 is 12. Okay, so how far is it from 65.8 to 80? 80 minus 65.8 is 14.2. Divide that by the RMS error, so 1.18 SDs. Now I can shade norm. Maybe. So I want to go from 1.18 up to 5. And last time I did this, I ended up with what, 8.5%? And now I have 12%. So, 5%. The first time I ended up with 5%, but now we're looking at people who did better on the midterm, which means they'll probably also do better on the final. Yeah, 11.9, 12%. All right, number 6. In a study of high school students, a positive correlation was found between hours spent doing homework per week doing homework and scores on standardized achievement tests. The investigators concluded that doing homework helps prepare students for these tests. Does the conclusion follow from the data? Yes or no? And statistics is the eternal maybe, right? Was this an observation or an experiment? Observation. Could it be true that homework helped people on tests? Yes. Could it be false that homework does not actually help? How would you explain that? The people who are going to do well on the test might already be doing homework, and the people who are not doing well on the tests don't do homework. Yeah. So it's a correlation. Is it causation? No. It might be, but we can't be sure. We would need to do a study. We would need to get a bunch of people, randomize them, make a certain group of people do homework and not let the other group do homework, and then take the test and then see. Do you think doing homework is going to help? I would say probably, but right. All right, and it depends on the test, right? Homework might help more on some tests than it does on other tests. Yeah, there's just so many variables in here. Number 7. The freshmen at a large university are required to take a battery of aptitude tests. Students who score high on the mathematics tests also tend to score high on the physics test. On both tests, the average score is 60. The SDs are the same too. The scatter diagram is football shaped. Of the students who scored about 75 on the math test, just about half scored over 75 on physics, more than half, or less than half. This is a really good question. So, math, physics, regression line, football. This point is 60-60. Right? 60 down here and 60 over here. If we look at the students who scored 75 on the math test. So if we go over here to 75, we only look at those kids. On average, would those kids average 75, more than 75, or less than 75? It's less. It has to be less. Why? Because tall dads have tall sons that are shorter than them. Right? It's the regression effect. If tall dads always had sons that were taller than them, what would happen? We would have a bunch of giants, and a bunch of little tiny people. So tall dads have tall sons, but tall dads, on average, have sons that are shorter than them. Now, every once in a while, or quite frequently actually, tall dads have tall sons that are taller than them. But if you look at everybody as a whole, the average would be less. So if we looked at the 75, and look at that, is there more area below the regression line or above the regression line? Below. And the regression line would be 75, 75. But it's not a perfect regression. You don't go right one SD and up one SD. You go right one SD and you go up R SDs. So we would say less than. 8. The bends are caused by, do you know what the bends are? When you scuba dive and you have pressurized oxygen and you're breathing pressurized air, you have to use pressurized air because the water pressure puts a lot of force on your lungs. And if you fill it with just normal air, your lungs will collapse. So you have to mash air into your lungs. Well, that's all well and good, except when you come up, you have all of this pressurized air in your system, and as the pressure releases, then there's a potential for your blood to boil because the pressure drops so much. If you took room temperature water and you put it in a container and you sucked out all the air, the water would boil. It wouldn't get hotter, but it would boil because it's on such low pressure. If you throw, yeah, it lowers the boiling point. A pressure cooker, so water boils here at about 207 degrees. You cannot heat water up more than 207. It's impossible unless you put it in a pressure cooker. And that raises the pressure and it raises the boiling temperature. So in a pressure cooker, instead of cooking at 207, you can cook at 240 or 250, depending on how much pressure there is. Now, you put water and antifreeze in your cars, and you heat your cars up to 210 degrees. If it was just water, it would boil. But it's not water, it's water and antifreeze, which raises the boiling temperature, and it's pressurized. Your radiator has about 15 pounds of pressure, which allows it to get up to 250, 260 without boiling. Okay, if you overheat your car, you heated it above its boiling point. Okay, so the bends, you have all of this pressurized air in your body, and pressure causes things to turn from gas to liquid. So you end up having liquid air running through your veins. But as you come up from scuba diving, the pressure lessens, and that liquefied air, oxygen and other things, starts to boil inside your blood veins. Nitrogen, yeah. It is really painful and it can kill you. So what you do when you're scuba diving, depending on how low you go, you might be able to be 10 feet under the water for 4 hours with your air tank. But if you go down to 300 feet, you might only have 5 minutes of air because you need a ton of pressure to keep your lungs full. But if you're down at 300 feet and you come straight to the surface, you'll die. You have to go up in little steps, and then you can turn that liquefied nitrogen and everything else back into air. And then you just breathe it out. So basically, you go down and you have one really long breath as you come up, right? Because that pressure, as you come up, your lungs expand because there's not as much pressure on it. And you cannot scuba dive and fly in the same day. Yeah. So if you fly in an airplane at low pressure, you can get the bends. So the bends is that pain caused by coming up too fast. And it will kill you. I mean, there's no doubt. Okay, so sorry. The bends, caused by rapid changes in air pressure resulting in the formation of nitrogen bubbles in the blood. The symptoms are acute pain and sometimes paralysis leading to death. In World War II, pilots got the bends during certain battle maneuvers. It was feasible to simulate these conditions in a pressure chamber. As a result, pilot trainees were tested under these conditions. At the beginning of their training, if they got the bends, only mild cases were induced. They were excluded from the training on the grounds that they were more likely to get the bends under battle conditions. This procedure was severely criticized by statisticians, and he persuaded the Air Force to replicate the test, that is, repeat it several times for each trainee. Why would he have suggested this? The regression effect. If you got a high score once, you'll probably get a lower score later. So it may have just been random error. Right. Give another example where replication is helpful. It's always good to do things twice, right? Doing it 2 times is better than once. Doing it 3 times is better than 2. Okay, every year, baseball's major leagues honor their outstanding first-year players with the title Rookie of the Year. The overall batting average for the Rookies of the Year is around 290, far above the Major League batting average of 260. However, Rookies of the Year don't do so well in their second year. Their overall season batting average is only 270. Baseball writers call this the sophomore slump. The idea being that star players get distracted by outside activities like product endorsement and television appearances. Do the data support the idea of the sophomore slump? I would say no. Why? So you could state the regression effect, but I think there's something else going on. When do rookies get a lot of playing time in the major leagues? Probably not. When would they be playing? When they're a long way ahead or when they're a long way behind? What sort of pitchers do they put in when you're either winning by a ton or losing by a ton? The bad pitchers, right? You don't want to waste a good pitcher if you're up 10 runs. So you'd put in somebody else. Is it easier to hit off those pitchers? Yeah. So it probably has more to do with when they get an at-bat. They don't get at-bats in the really tight games where the really good pitchers are playing. Does that make sense? But it could also be the regression effect. 10. A study was made of the relationship between stock prices on the last trading day of 2005 and the last trading day of 2006. A formula was developed to predict the 2006 price from the 2005 price using 100 stocks. An analyst is now reviewing the results. Data are shown below for 5 out of the 10 stocks. Prices are in dollars. Was the regression method used to predict the 2006 price from the 2005 price? Yes or no? So it's asking, was the regression method used to predict the prices? And you would say no, why not? So 10 predicted 8, 10 predicted 8, 12 predicted 13, 14 predicted 12, and 15 predicted 20. So 14 is lower than 12, right? If it is a regression model, then it should be linear. You should be able to graph those points and make it linear. So they must have used some other method. It's obviously not linear. We went ahead 2 years, up 5,000 in price, or sorry, up 2,000, up 5,000, and then 14 actually ended up being lower in its prediction. Okay, the figure below is the scatter plot of incomes against education for a representative sample. Or is that a question? The figure below is a scatter plot of income against education for a representative sample of men aged 25 to 29 in Texas. Or is something wrong? That's not a question, right? I don't know what that. Maybe it's supposed to say is 11. Or is something wrong? I don't know what that means. But it's not, there's no question. It just says, or is something wrong? Well, that's how old the men are, and then it's education versus income. What's not there? Well, but so it's the men are 25 to 29. So those men have anywhere between 2 years of schooling to 23 years of schooling. But there's no question in the it says it is a scatter plot or is something wrong. I don't even know what it wants to. Yeah, don't know. Number 12. So you have all that information. One man in the sample had 20 years of education and his blood pressure was 118. True or false? Compared to other men at his education level, his blood pressure was a bit on the high side. So all we have to do here is calculate. So we have X bar at 13, Y bar at 119, and so we're going to go up to 20, which is plus 7. Divide that by 3. 7 divided by 3 is 2.3 SDs. So we go up 2.3 SDs, and then we cut it off. Oh, it's actually going the other way. Sorry. R is down, right? The more schooling you have, the less blood pressure. So anyway, we go right 2.3 SDs. We go down 2.3 SDs, but not all of it. We times it by negative 0.1. And then I multiply that by the SDY times 11. And what do I do with 2.53? I subtract it from the 119. So 119 minus the answer. That is the new predicted average. Well, that is the new average, the actual average. So people who are 20, who have 20 years of education, average 116 on their blood pressure. So the man who is at 118 is higher than average. So, true. Okay, I still haven't figured out that number 11. I don't know. All right, that's it.